Hi, I'm Anup.
And I'm Matthew Stallone.
And what we created was a device to help the blind and visually impaired by digitally mapping the room around them and informing them of obstacles. So that's what this title is. So yeah, when we created this device, we looked at the ways that the blind were using to get around their daily lives. And we found that the devices were hilariously outdated. Like, they use canes and guide dogs, which can only detect obstacles once you physically run into them. And so what we wanted to do was bring this technology into the digital age. So when we looked at research that's being done into this, we found that the devices use technology that's not easily accessible or affordable, and others were very hard to use and required hours of training. So we wanted something that was easy to use and used accessible technology such as Android and Arduino. So our device has two modes. The first mode will digitally map the room by using a servo connected to an IR obstacle sensor that will move up and down and graph obstacle sensor readings so that you can find obstacles in the room. And the second mode will use audio feedback to let you know about obstacles so that you can just put in headphones and walk around without having to run into anything.
Okay, so we strive to polish some key features that we thought were mandatory for the device. The first one is connectivity. We wanted to make sure that the device connected automatically and flawlessly with the phone, because you can't go through settings trying to connect it when you're visually impaired. The second one is true distance. You can't say an object is 6 feet away when it actually is only 6 inches away. So we had to create a regression between the sensor's values to the distance. The other one is the design. The mobile experience is quite a unique one. It fits in your pocket, you can't carry it around. And we wanted to build off that, so we created a slim phone case that can fit right onto the phone. And finally, we wanted it to be easy to use. So we split the screen into two spots. The bottom half is for changing the mode, and the top half is for getting user feedback. So our project is split into two different parts, the Arduino part and the mobile part. The Arduino part pretty much just emits the sensor's values and checks if it received any data from the Arduino or from the mobile side, and if it has, it would act upon that, such as changing the sensor's position. The Android part is a little more complicated. It is split into 3 independent threads. The first thread is the user interface thread, which checks if the user is doing anything on the screen. The second one is the auditory feedback thread, which processes the values and makes the tone or calculates the distance using the regression. And finally, the most complicated thread is the digital input stream processing, because when the Arduino sends out signals, it sends it out in a prolonged message, so you can't discern between two different messages. So we had to add bits in the output so that we can find those bits on the mobile side, so we can say, okay, this is one value, this is the next value. And we've prepared a short video showcasing the first prototype of the app with the tone-based feedback.
Actually, the audio feedback it gets. So
the higher the frequency is, the closer you are to an object. And when you actually have headphones in and not recording to a phone and doing video, you can actually hear the different frequencies and when you can see the distances.
It's actually pretty sensitive, so you can detect obstacles from quite a distance away, much farther than you would be able to with a cane. Grab obstacle sensor data so that when the obstacle sensor moves up and down, you can detect the obstacles.
So applications. Well, there's the consumer application for helping the visually impaired navigate through an unfamiliar environment. However, we also feel that our algorithm that we created for mapping the room around us, such as in this picture, you can see mapping up, you can see the graph of it. Seeing the distances, we feel that that can be used in other applications, such as robots moving around anonymously.
And finally, future improvements. First of all, our case was fairly large, so we wanted to make it smaller and probably 3D print the case so that we could fit it in our pocket. Another thing is we would use pyroelectric sensors which can detect body heat, and so we would be able to tell between human and non-human obstacles, which would obviously be great for our device. And then finally, we would have 2 servos so that we could detect in a 2D field of motion instead of just in one line. So you would be able to detect obstacles in your whole field of view. And finally, instead of the obstacle sensor that we had with the Arduino, we would use an ultrasonic sensor or some kind of obstacle sensor with better range. So we'd like to thank our professors, Ryan and Kurt, our teacher fellow Shirley, and our TAs, Luis, Christy, and Justin.
Okay, the award for this project is the most hated by the White Cane Makers Association of America.